morning everybody. So today we're going to be using everything that we looked at last week in capacity, and we're going to have a go at using that today practically, as well as I've got some problem solving for you to do at the end of the lesson as well. I'd like you to start off by having a go at using the less than, greater than or equal to sign to compare the different fractions here. Now what I would suggest doing is, if you are unsure on how to do these, look at the denominator, look at the numerator. You might want to draw your bar models to show to see which one is bigger as well. So please have a go at doing that, and then I will go through the answers after. Okay, so we're going to have a look and see if you have got the same answers as me. So if I have a look at my question, so the first one, 5/7 and 2/7. Now I've drawn my two bar models that are the same length, and then because the denominator is sevenths, I know that there are going to be 7 parts, so I've drawn 7 parts in each. Now I'm going to have a look to see which is going to be bigger, so I know they've both got 7 parts. If I shade in 5, 3, 4, 5, so that shows 5/7. If I'm shading 2/7 on my next one, we can see that 5/7 is greater than 2/7. We could also see that because they've both got the same denominators, so they've both got the denominator of 7, we know that the parts are going to be the same number of parts. So if they've got the same denominator, the greater the numerator, the greater the part. So if I use that for the next one, so I've got 4/9 and I've got 8/9. If I first of all look at my denominator, I can see my denominator, both of them are 9. So I can see that because both of my denominators are 9, I can see that they're going to be the same if I was to draw it as a bar model, and I can see that 8 is more than 4, so I could say that 4/9 is less than 8/9. If I was to check this, I could draw a bar model. So now I have drawn my bar model. If I coloured in 4/9, 1, 2, 3, 4, and then coloured in 8/9, 2, 3, 4, 5, 6, 7, 8, we can see that 8/9 is greater than 4/9, or if we say it this way, 4/9 is less than 8/9. So if we had a look at my next one, 5/10 and 4/10, again we can see they've got the same denominator, so we can see that we can look at our numerator and see which one is bigger. We know that 5/10 is greater than 4/10. Okay, let's look at the next one. Again, we've got the same denominator, so I can look at my top number. I can see that 2/4 or 2/4 are less than 5/4. Now, 5/4 is over a whole. So if we were to draw it, it would look something like this. So if I had 2/4, I would shade in 2/4. Now if I had 5/4, remember I've still got 4 as my denominator, so I would need 4 parts, but this time I've got 1, 2, 3, 4 and 5. So I would say that 5/4 is the same as 1 whole, because I have 1 whole and I have got 1/4 left over. So we know that it will be bigger. Okay, so having a look at this one, I look at my denominator again, and this time my denominators are different. However, my numerators are the same. So I'm going to draw out my bar models. Again, they're going to be the same length. However, this time, one is going to have 2 parts, so I'm going to split it into 2 parts, and one is going to have 3 parts, so I'm going to split it into 3 parts. Now if I was to shade it, so in this one, and I've got 2 parts, I want to shade 1 of it, and if I had 1/3, I've got 3 parts because that's my denominator, I'm going to shade 1/3 of it. We can see that 1/2 is greater than 1/3. Now if you imagine that these were bars of chocolate, if you were sharing between more people, you would have a smaller piece of chocolate. So for example, if I had a bar of chocolate and I gave 2 people, I was sharing it between 2 people, each person would have the same amount. However, if I was sharing it between 3 people, I would have to give a smaller amount to each person to make it fair. So we can see that the rule would be, if the numerators are the same, but the denominators are different, the smaller the denominator, the greater the amount, because it's a smaller number, so you'd have more of that part, you'd have more chocolate. So bearing that in mind, let's have a look at the next one to see if you got that one correct. So this time I can have a look again. My numerators are the same, so I can look at my denominators, and I know if I was sharing between less people, so if there were only 4 parts compared to 9 people, 9 parts, I know that this would be my bigger fraction, because if I coloured what 1/4 would look like and I coloured what 1/9 would look like, I can see that a quarter is greater than a 1/9 because you're sharing your chocolate with less people, so you would get a bigger piece. Okay, let's have a look at the next one then. So this one, if I look at it again, I've got the same numerator of 1, I've got different denominators. If I was to see, if I was sharing between 7 people compared to 5 people, I would have a smaller amount of chocolate. So I would say that 1/7 is less than 1/5, because if I shade in what 1/7 would look like, showing what 1/5 would look like, I can see that a 5th is going to be greater than a 7th. Okay, so I'm going to show you how to do this one, to have a quick recap to see what we can remember, and then you're going to have a go at doing the next questions. So this time, if I have a look at my question this time, I can see that my numerators are different and my denominators are different. Now what I could do is I could use my bar models, again the same length, and I could split them into parts. So I've got parts of thirds and I've got parts of fifths, because that's what my denominator is. Now if I look at my numerator, I want to shade in 2/3 and I want to shade in 3/5. So we can see straight away that 2/3 from looking at my picture is greater than 3/5 because it goes across further. Now if I didn't use bar models, I would need to find an equivalent fraction. So I'm going to show you how to do that, see if we can remember. So in order to compare them, I need to have where the denominator is going to be the same. Now I need to think of a number that both of these denominators go into. So let's pick the biggest number, 5, because that's bigger than 3, and let's count up in 5s until we find another number which 3 goes into. So if I start 5, 10, 3 can't go into 5, 3 can't go into 10. If I count up to the next one, 15, can 3 go into 15? Let's check. 3, 6, 9, 12, 15. Yes, it can. Can 5 go into 15? Yes, it can. So I can make my denominator as 15. Now, I want to know how I get from 5 to 15. What am I going to multiply it by? Well, if I count up in 5, so I'll get to 15, 5, 10, 15. I'm going to multiply it by 3. Now remember the rule, whatever you do to the bottom, you must do to the top. So I'm now going to times my top by 3 because I've times 5 by 3 to get 15, and I'm timesing 3 by 3. So if I do 3, 6, 9, I know that my equivalent fraction is going to be 9/15. Now I'm going to do the same on this side. So how do I get from 3 to 15? Well, I'm going to cancel with my 3's. 3, 6, 9, 12, 15. And I'm going to times it by 5. Now remember the rule, whatever you do to the bottom, you must do to the top. So I'm going to do 2. I'm going to times it by 5. 2, 4, 6, 8, 10. Or you could have done 5, 10. And I will find that my equivalent fraction is 10/15. Now, if I look at my equivalent fractions and I ignore my other fractions, so I cover up my other fractions, I can see I've got 10/15. I've got what I'm going to compare it with, and I'm going to cover up this part, and I've got 9/15. So now, because they have got the same denominators, I can look at my numerators, and I can see that 10 is greater than 9. So I would know that 2/3 is greater than 3/5 from either drawing it as a bar model or from finding an equivalent fraction. So I'd now like you to have a go at doing the next one. Okay, so I'd like you to have a go at doing this one. I want you to compare 3/4 and 2/5. Again, using my method that I've used here, you could choose to draw it first to see, Or you can use your to find an equivalent fraction. Actually, I would like you all to try and find the equivalent fractions. I will leave this here to help you. Look at how I have found. Remember, I need a denominator that both of my bottom numbers will go into. So you'll have to count up in your times tables to find what that is and then work it out. Once you have worked it out, press play and we'll see if you have got it correct. Okay, so you should have had a go at drawing out and it should look something a little bit like this. I'm just going to finish just to tweak that. Okay, so you should have had a go, and you should have, if you'd have coloured in your bar models, you would have seen that 3/4 is greater than 2/5, because if I shade in 3 parts on my or 3 of my 4 parts or 2 of my 5th parts, I can see that 3/4 is greater than 2/5. Now to check it, we're going to find our equivalent fractions. So I'm going to write equals because I want to find my equivalent fraction, a fraction that is the same. I'm going to look at my denominators. I've got 4 and I've got 5. I need to find a number that both of these numbers go into. So I'm going to start with my biggest number and I'm going to count up in my 5s. 5, well 4 can't go into 5. 10, 4, 8, 12 doesn't go into 10. 15, let's count it up, 4, 8, 12, 16, doesn't go into 15. 20, 4, 8, 12, 16, 20, fantastic, it does. So I know that 20 is both in the 4 times table and it is in the 5 times table. So I know that my denominator is going to be 20. Now I want to know how I can get to 20. So if I'm going from 4 and I want to get to 20, how many times do I have to times 4 by 20? Let's count it. 4, 8, 12, 16, 20. So I'm going to times it by 5. Now remember the rule, whatever you do to the bottom, you must do to the top. So I'm going to again times it by 5. 3 times by 5, 5, 10, 15 is 15/20. I'm going to now find the equivalent fraction on my other side. How do I get from 5 to 20? 5, 10, 15, 20. I'm going to times it by 4. Remembering what I do to one side, I must do to the other. So I'm going to times 2 by 4, 2, 4, 6, 8. So I can see that it is 8/20. Now if I check my answer, if I look at my denominators now, my denominators are the same. My numerators are different. 15 is greater than 8, so I know that 3/4 is greater than 2/5. If you're still unsure about that, have another look at that and see if you can now understand that. Okay, so I'd like you to have a go at doing this one now, and please use the method that we've had a look at doing, and then once you've had a go at doing the method, please press and finding the answer, please press play and have a look to see how to work it out. If you need to push back onto the previous slide to see the working out, please do that as well. So let's have a look at how we would work this one out. So if you were to draw your bar model, I've got 5 parts. If I shade 4 out the 5 parts, which is what my fraction says, because it's saying 4 parts are shaded, 5 parts in total, then I shade my 3 parts from my 8, and I can see that 4/5 is going to be greater than 3/8. Now if I was to work these out as equivalent fractions, again I need to find a number that both of these numbers would go into. So if I start with my biggest denominator first, and I count up in my 8, does 5 go into 8? No, it doesn't. My next multiple of 8 is 16. Does 5 go into 16? No, it doesn't, because it doesn't finish in a 5 or a 0. 8, 16, 24. 5 doesn't go into 24. 8, 16, 24, 32. Does 5 go into 32? No, it doesn't. Remember, this is just my 8 times table. 32, 40. Does 5 go into 40? Yes, it does, because it ends in a 0 or a 5. So I know that my denominator is going to have to be 40. Now, I need to find an equivalent fraction. So if I'm trying to get from 8 to 40, I need to count how many times I would multiply this. 8, 16, 24, 32, 40. So I'm going to times by 5. Remember, what I do to one side, I must do to the other. So I'm going to times by 5 up at the top. 3 times by 5, 5, 10, 15. I know my equivalent fraction is 15/40. Then I'm going to have a go at doing it on this side. I'm going to go, how do I get from 5 to 40? Well, I know that I'm going to times it. 5, 10, 15, 20, 25, 30, 35, 40. I'm going to times it by 8. So again, what I must do to one side, I must do to the other. How do I get from 4? I need to times by 8. So 4 times by 8, you can do your 4s or your 8 times tables. 8, 16, 24, 32. So I have got my equivalent fractions. Now, because my equivalent fractions have got the same denominator, I can look at the numerators and I can see that 32 is greater than 15. So I would work it out this way. So now I've shown you how to do that, I would now like you to have a go at doing these 4 questions here. Please as well show me your equivalent fractions. If you feel like you can just use your equivalent fractions and you don't need to draw it, that's absolutely fine, but if you do need to draw it, please draw it on a bar model. And once you've done that, press play and we'll see if you've got them correct. Okay, so let's have a look at the first one. So I'm going to find equivalent fractions because I've got the different denominators and the different numerators. So what number do both 3 and 5 go into? I could say that they both would go into 15. So that is going to be my denominator. Then I'm going to find out how do I get from 3 to 15? Well, I'm going to multiply by 5. So remember, what I do to the bottom, I must do to the top. So if I times 2 by 5, it would be 10. Alternatively, if I go from 5 to 15, how do I get from 5 to 15? Well, I'm going to times by 3. So I'm going to need to times my top by 3 as well, because remember what we do to the bottom, we must do to the top. 4 times 3 is 12. So I can see my equivalent fractions are 10 fifteenths and 12 fifteenths. So now I can see which one is greater. Well, 10 is less than 12 because I've got the same denominator. So I would say 2/3 is less than 4/5. If I was now having to go at doing the bottom one, again, I need a number to find an equivalent fraction where my denominators are the same. What number goes into both 5 and 4? What multiple would it be? 5, 10, 15, 20. I would know that 20 could be my denominator because 4 and 5 both go into 20. Then I would do, how many times does 5 go into 20? Well, that's by 4. So I could times my top number by 4. 1 times 4 is 4. Then I can do the same on this side. How do I get from 4 to 20? I times by 5. So I'm going to times my top number by 5. 3 times 5 is 15. So I've now got 4 20ths and 5 20ths. So I know that I could say that because I've got the same denominator now, 4 is less than 15. So 1/5 is less than 3/4. Let's have a look at the next ones then. Okay, so let's have a look at the top one. So I need to find some equivalent fractions because the numerator and the denominator are different. So if I count up in my 4s, 4, 8, 12, I know that 3 also goes into 12, so my denominator will be 12. I then want to know, how do I get from 4 to 12? Well, I'm going to times by 3, because if I do 4, 8, 12, I'm timesing by 3. So I must times the top number by 3 as well. 2 times 3 is 6, so I know 2/4 is equivalent to 6/12. Alternatively, if I'm going from 3 to 12, 3, 6, 9, 12, I'm timesing by 4, so I must times my top number by 4. 1 times 4 is 4. Now if I look at these two numbers, they've both now got the same denominator of 12. If I look at the numerators, 6 and 4, I know 6 is greater than 4, so I know 2/4 would be greater than 1/3. Finally, the last question, again I need to find an equivalent fraction. Now you could have gone bigger, however if we look at these two numbers at the bottom, we can see that 8 is already a multiple of 4, so I could still keep 8 as my denominator because 8 goes into 8 once, so I'm going to times my top number by 1, so that'll be the same. So it'll be the same on this side. However, to get from 4 to 8 I would times by 2. So I would times my top number by 2, and so I can see that I would find that 2 8 is the same as 1/4 because 2 8 is equivalent to 2 8 and 1/4 is equivalent to 2 8, so it's the same. Well done if you have got that. You can also make up your own questions if you want to do some more practice on that as well. Okay, so moving on to the activity then for today then. So we're going to be doing it quite practically. Unless you cannot do this practically, I have given you some more questions as well. So if you can do this, I want you to find a measuring jug around the house, or if you're in school, see if you're someone in school you can have a go at doing this. You might need a parent to help you to ask if they've got a measuring jug for you to be able to be looking at millilitres and litres. Then I'd like you to fill the jug with some water and write how many millilitres and litres there are. You could then pour this back into a bucket or a washing up bowl or something that you could pour the water back in rather than just putting it down the drain, and then you could pour it out and refill it again, and this time to see what the capacity and the volume is again. So we can see, so you're practicing actually you filling up a jug and actually reading out how much of the liquid is in there. You could also have a look in the fridge or around, if you've got some juice around the house, to see what things are measured in, and you could write these down. So for example, if you had some cream in the fridge, you could write single cream and you could tell me how much was in and what the capacity was of a pot of single cream. It could be 500 millilitres, it could be 250. Same with the orange juice. Now obviously things like milk are different because they are in pints. However, they might say on the jugs or on whatever the object is, it might also say millilitres as well. So have a look at millilitres and litres. Now if you cannot do that, I'm going to show you another activity that you could get on with. You could also have a look at doing some baking this afternoon or doing some baking this morning to practice using the different recipes with your parents. If you can do that, have a look at using things like millilitres, litres, again grams and kilograms, to have a go at doing that. Or you could have a look at some recipe books to see where they have used millilitres and litres. So for example, we can see that this recipe here for making a smoothie, it has got the fruit and then it has 100 millilitres of orange juice, so we can see that's how millilitres are used. If you cannot do that or you don't want to do that, that's fine. Have a look at the next activity where I'm going to start to give you some problems. So I'd like you to have a go at doing some of these word problems. Now you will have to pull out the keywords. So for example, you might want to write these down, the keywords. I'm going to underline them so that they're nice and clear. So we can see that Jenny needs to take 5 millilitres of medicine one time a day. How much will she take in 1 week? Well, I know that in a week there are 7 days, so I could write that down. So I could write down 5 millilitres once a day, and she wants to know how many she has in a week. Now I know in a week there are 7 days. There are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So there are 7 days. So we would know that I want to know if you take 5 millilitres each day, so 5 on Monday, 5 on Tuesday, 5 on Wednesday, 5 on Thursday, 5 on Friday, 5 on Saturday, 5 on Sunday, I could do there. I'm going to have 7 lots of 5 millilitres because there are 7 days and she's taking 5 millilitres a day. So if I do 7 times 5, I would do my 5 times table for this: 5, 10, 15, 20, 25, 30, 35. Don't forget to put your millilitres on the end. Her answer would be she would have 35 millilitres that she would take in a week. So I'd like you to have a go at doing this. You might want to do what I've done here, writing down the keywords, taking out what you understand from the question, showing me your working out, and then writing your answer. Don't forget though, you must tell me the unit of measure, whether it's millilitres or litres. Once you've had a go at doing that, I will also go through the word problems after to see if you have got them correct. I went through number 1 on the last slide, so we're going to start with number 2. So if 1 bucket, you could even draw the bucket, holds 2 litres of water, how many would 9 buckets hold? So you could have either drawn 9 buckets, 1, 2, 3, 4, 5, 6, 7, 8, 9, and each has got 2 litres in it. So I could write 2 litres in. I want to find out how many 9 buckets would do. So there are 9 buckets and there are 2 in each, 2 litres in each. So I would do 9 times 2 litres equals 18 litres. So that would be your answer. Or you could have gone 2, 4, 6, 8, 10, 12, 14, 16, 18. There are 18 litres in total. Number 3, if a doll's cup holds 2, so a doll's cup, so again I can do a cup, I could draw it if I wanted. In a cup, it holds 2 millilitres. It then says, how many cups would it take to fill a doll's 10 millilitre bottle? So I want to know how many times would 2 go into 10. So I could either draw it, so I could find out. So there's 2 millilitres, another 2, so that's 4, 6, 8, 10. So how many cups have I got? 2, 4, 6, 8, 10 millilitres. So I would need 5 cups. Now to work it out, what you also could have done, I need to get to 10 millilitres. I've got each one holds 2 millilitres. So I could do 10 divided by 2, which will be 5 cups. You don't even need to put measurements in there. So I can see that 10 divided by 2, she would need 5 cups. And you must have said cups to show what the unit is. Number 4, at a party, Sam drank 42 millilitres of lemonade. So that's how much she drank. And she had 28 millilitres of orange juice. How much did she drink altogether? Now remember, if you see the word altogether, we mean it's going to need a bigger number. So we're going to need to be either adding or multiplying. If we want to know if you've drunk 42 millilitres, you've drunk 28, we want to all together, so we're going to add them. So you should have done 42, add 28. You could have used column method. Alternatively, you could have done 2 add 8 is 10, add 2 lot more 10s, which is 30, add 4 more, which is going to be 70. So and remember, we need to put millilitres after, so she will have drunk 70 millilitres. Question 5. Jessie started with 56 millilitres of orange juice. I'm just going to put 56 millilitres of juice. It then says that her friend started to visit, and her friend, she drank 24 millilitres. Drank 24 millilitres, and it says how much did she have left. Now when it says how much does she have left, we need to find a smaller number. So I know that I'm going to need to take away to find a smaller number, because it says I started with 56 and the friend drank 24. If I do 56 take away 24, all I can do in my ones column, 6 take away 4 is 2, 5 take away 3 is 2. There are 32 millilitres left. You could have also used column method to work that out. Okay, number 6. Jenny needs to take 5 millilitres of medicine, but this time she's taking it 3 times a day. And we want to know how much she will take in one day and how much she will take in 1 week. So in one day she's taking 3 lots, so she's got to have 3 times a day. And because it says times there as well, I want 3 times, or 3 lots of 5, which is going to be 15 millilitres she'll take a day. I know that there are 7 days in a week, so I'm going to do 7 times how much she takes in one day, which is going to be 15 millilitres. Now, to work it out, we could use our column method. So I could do 15 times 7. I know if I do 5 times 7, 5, 10, 15, 20, 25, 30, 35, I would write my 5 in my ones column and my 3 under my 10s. Then I would do 1 times 7 is 7, add your 3 that we need to make sure, 8, 9, 10, and again, I can't write 2 digits, so my 0 would go in my 10s column, my 1 would go in my underneath my hundreds. There's nothing in my hundreds column if I wrote that up a bit, nothing in my hundreds column, so nothing times 7 is nothing, add 1 is 1. So she would have 105 millilitres in a week. Let's have a look at number 7 then. So in 1 bucket is 7.5 litres. How many would be in 9 buckets? So you could have drawn 9 buckets. Alternatively, you could have said, well, I know that there's going to be 9 buckets. There's going to be 9 lots of 7.5. Now what I could do for this one is to work this one out. I could either convert it so it's all into millilitres and times it, or if I take out my decimal point for now, I want to do 9 times 75. So I'm just going to take out my decimal point. I'm going to do 9 times 75, and I'm going to use my column method. 9 times 5 is 45. 7 times 9 is 63. Add 4, 64, 65, 66, 67. and nothing in my hundreds column, so nothing times 9 is nothing, add 6 is 675. However, if I look at where my decimal point is, I need one number after my decimal point, so I can put my decimal point before, so that I've got one number after it, so that your answer should have been 67.5 litres. That was a really difficult one, a real challenge, so well done if you got that correct. Alternatively, you could have done 9 times 7, first to find 63, and then find 9 times a half or 0.5, so you could have done a half, a whole, so that's 1 half, 2 wholes, half, 3 wholes, half, 4 wholes, and we've got 4.5, so we could have added 63 at 4.5, which would have obviously got us the same answer. Okay, number 8, so a cup holds 250 millilitres. We want to know how many cups would make, how it would take to make a 5 litre bottle. So I want to know how many lots of 250 millilitres go into 5. Well, let's find out. If I do 250 and count up, now 250 is counting up, that's going to be quite hard, so let's count up in our 25. So 25, let's double that, it's going to be 50, add another 25 is going to be 75, add another 25 is going to be 100. Now if I put on my zeros on the end, and they are all millilitres, I can see in 1 litre, because remember 1,000 millilitres in a metre, in 1 litre there are 4 lots of 255. So in 1 litre is 4 lots of 255. So in 5 litres, I want 4, because there's 4 lots in each, and I'm going to times it by 4, and I'm going to times it by 5, because I've got 4 lots of 250, times it by 5 because there's 5 litres, which is going to be 20. So again, this was another challenge, so you would need 20 cups, because 20 times 250, if we check that, 250 times by 20, take off our zeros first, so 25 times by 2 equals 50, but then you've taken off your 2 zeros, you must put your 2 zeros back on, which would get 5,000, which is the same as 5 litres. That one was a difficult one. Now these ones are a little bit more of a challenge to just challenge those people that are really pushing themselves. Okay, number 9, so it says at the party Sam drank 200 millilitres of lemonade. It also says she drank 0.5 litres of Coca-Cola. Coca-Cola. And 300 millilitres of juice. And then it says how much did she drink altogether. Remember, when we see that altogether, it means we're looking for a bigger number. So I'm going to add all of these together. However, before we can add them together, I can see that these ones are in millilitres and this one's in litres, so I'm going to convert it. So I'm going to turn them all into millilitres, so 200. If it's 0.5 of a litre, it's half a litre. I know that in 1 litre there are 1,000, so half of 1,000 is 500. Add 300 millilitres. Now, because I've all got 2 zeros on, let's just take off the zeros for now. 2 add 5 is 7, add 3 is 10, and then because I've taken 2 zeros off, I need to put my 2 zeros back on. So it says that she will have drunk 1,000 millilitres, or 1,000 millilitres is equivalent to 1 litre. So now we're going to have a look at an extension activity if you've done all that. So it says, can you write a word problem using the potion here? So can you then solve it? So using the clues from the measurements on the potion bottle, could you think of a question? So it could be something like, Sarah was making a magical potion. She wanted to know how much of each ingredient there was and what the ingredients were. Can you tell, can you work out how much each ingredient was worth? The answer then could be, you could work it out so that the purple liquid, say how much that was, the orange liquid, say how much that was, the green liquid, say how much that one is, and obviously the top is the clear bottle. It could also be that you ask something like to say that a certain ingredient has the most amount in the potion, how much would that be, so that they've got to apply it. So you could have a go at doing a couple of your own word problems and then having a go at solving them. Then the final part, the final extension, is Gavin the Goblin has mixed some potions, but he has forgotten to write down the recipes. Can you work out which ingredients are in each bottle by looking at the shelf below here? So I want you to use the ingredients to help Gavin write down the recipes. So for the first one, we need to first of all work out what each, how much is in the potion, and then we can work out which ingredient it is going to be. So you can have a go at doing this as well. Let's have a look at the answer for this one. So for number 5, for the potion that's in there, we can see that at the bottom, we can see that there are, let's have a look, 50 millilitres of something, because I know that that's what the bottom part is. And then if the next part is 50 millilitres and goes up to halfway between 80 and 90, that would be 85. So if I find the difference between 50 and 85, if I count up in tens first, 50, 60, 70, 80, plus the 5, that would be 35 millilitres of something else. And then finally from 85 up to 100, that is 15 millilitres. So I know that they're the ingredients. Now I need to look on the bottom to see which one is worth which. So I could have dragon blood, which is my 50 millilitres. 35 millilitres is my teacher's tears. And the final 15 is snake oil. Now these could have been what you have got. You could have as well, actually, say for example for 35 millilitres, you could have said that it was snake oil and brainy broth, because you could have added the two together. For number 6, we've got 25 millilitres of something. Then we need to go from 25 up to 65, so 25, 35, 45, 55, 65, so that's 40 millilitres of something else. Then we go from 65 up to 80, which is 15 millilitres, and 80 up to 100, which is 20 millilitres. So if we now look at the bottom, we can see that I've got 25 millilitres of slug slime. I have got 40 millilitres of nettle soup. I have got 15 millilitres of snake oil. And I've got 20 millilitres of brainy broth. So I have worked it out there. Ooh, there we go. So once you've had a go at doing this, please make sure you do put it on Seesaw, and so I can have a look at your fantastic working out.